I think would be important. And then if you guys have more questions from the multiple choice, I'll happily answer them. Okay, so we talked about this, the rounding, and I want to make it really clear that you're rounding to 3 decimal places, even where it seems a little bit weird, like when you have number of cars. I think that was in our FRQ. It was like, the answer was like negative 16.333 or something. And I know in other classes we talk about we don't have 0.33 cars, so we don't do that. But on this test, you will do that, okay? So just remember that. Make sure you know about limit notation and how to write it. There's going to be, in one of those FRQs, you've already seen it, where you have to write the limit notation. And so we always do LIM, abbreviated, and then you're going to fill in this blank. It could be f of x, g of x, h of x, whatever the name of the function is, which you don't have to guess, you don't have to make it up, it'll be in the word problem, right? As x approaches, and then whatever it told you to, you'll fill that in. So I'm just going to make stuff up here. F of x maybe, a lot of times it's infinity here, or negative infinity, equals, and then whatever, maybe negative infinity, whatever it may be. But just understand how to write limit notation. And remember, if you see approaches from the left and from the right, that's when you put that little negative symbol. So negative is from the left, positive is from the right. Okay, it goes with the number line. Okay, I keep seeing this notation, and we're still getting confused by it. When you see this, this is basically just an ordered pair. This is your input, and this is your output. Okay, and a lot of times they'll give you f of x equals like 7. That means y equals 7. It was in your. I want to show it to you because I feel like a lot of these copies. Oh, okay, so when you are given like an FRQ4, it says g of x equals 3, that's y equals 3. So you're setting g of x equal to 3 and solving for x, okay? That means y equals e to the 1/2. So you put e to the 1/2 in place of the h of x. So I saw a lot of questions about that. Okay, so understand that's what that means. There's something called linkage errors that we've never really talked about in this class. I've never really referred to it as that, I guess. But here's a bad example and a good example of a linkage error. Like you wouldn't write 3 plus 5 equals 8 plus 2 equals 10. Okay? What this is saying is 3 plus 5 equals 8, and then we take the 8 plus 2 equals 10. This is not a true statement. 3 plus 5 does not equal 8 plus 2. Okay? So 3 plus 5 equals 8, and then you're doing another computation, adding 2 to that and getting 10. So be careful with that. We want to use, proper notation and language. Okay? Remember that inverse, whenever you see inverse, why did I write it like that? Inverse, when the symbol is, f to the power of -1, that's what the symbol looks like, okay? You are switching x and y. We saw it in a graph, like, what is the range of the inverse? It's just the domain of the actual function. You're just switching x and y. If it's in an equation, then you solve for y again. Okay, so that symbol There's definitely going to be some inverse questions. Some fraction tips. When you have to do fractions by hand, don't forget that, like if you had to do something like this by hand without a calculator, you could change that to a fraction and then keep, change, flip, -2/1, which would be 4, okay? Don't forget fractions. With fractions in them, we do the keep, change, flip. Here's another one. 2x equals 1/2. You know, to solve for x, I would divide by 2, but that's the same as multiplying by the reciprocal. So when would I want to do the multiplying by the reciprocal step instead of dividing by that value is when I have a fraction on the other side, okay? So be okay with dealing with fractions without a calculator. That used to really not scare you at the beginning of the year, but you guys were not great at it at the beginning of the year. And, you know, we've done so much with fractions by hand that I'm feeling much more confident for you. And one more thing I thought of in the calculator, when you have a division with anything in the denominator that involves an operation, adding, subtracting, multiplying, dividing, you have to put it in parentheses. Okay? Don't forget that. Okay. So that's what I kind of thought of so far. If there's more, I will let you know. But I wanted you guys to have this pink paper that was like a go-to place that has just some good last-minute reminders. If you weren't here yesterday, you definitely want to watch the video because I did go over this whole paper and I gave some information about tan tricks and stuff like that, so you might want to write those down, get them from a friend, whatever. So don't throw this away. Keep it. Do you guys want me to do any examples from any of the multiple choice? I can do anything from the calculator or non-calculator. And I'm just going to put this out in case anybody wants to see the test questions again. We're doing some AP Pre-Calc exam reviewing. Yes. Monday. Look, they're scared.
I saw on Facebook all the little pouches you made.
Oh,
It's like
yeah.
those were so cute.
Yeah, I have something wrong with it. But, y'all didn't come in. But, you're going to stay for a while?
Well, I came to see how you were doing it. I said I asked if I could maybe borrow 6 graphing calculators
For when?
for after school.
Today?
Yeah.
And then you'll give them back to me, because I have the
Get
AP
back to
test
you.
Monday, so I have
Yeah,
to have them back.
I'll call you for the physical back
Yes.
tomorrow, but
Yeah.
we're doing an afternoon
Yeah,
tryout thing.
yeah,
So.
yeah. You can take 6 right from there. Those are freshly batteried. Yes. Yeah, no one's ever used them. Yeah, of course. Yeah, just make sure. Tell her I definitely need them back. Yeah, you know. Good to see you.
Congrats on graduation.
1 week.
Today was going to be my last day here, but Tuesday forgot to bring in the codes for academics, so I'll have to stop by again. I'm like, yeah, you can get an excuse to come back one more time. But
Yes. You like that, right?
yeah.
Well, congrats, congrats, congrats. Enjoy this time. It's special.
Thank you.
All right, bye, sweetie. Good luck at academic team competition.
Thank you.
All right, bye. All right. What did you say, Caitlin? Sorry. Number 20? Okay. All right, So number 20 was super annoying to me at first, and then I was like, oh, it's actually not that bad. So what you have to know, the whole point of this is it's not sine or cosine. But when they call it, so that's sinusoidal, but it's periodic, so the pattern repeats, okay, over and over and over again. And how often does it repeat? Every 11 units, right? Caitlin, is this the one you wanted? Okay. So from 0 to 10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 0 to 11, 0 to 11 is one cycle, okay? So this pattern repeats, every 11. So this will happen again from 11 to 22, and then 33, and then we won't make it to 44, right? So think about, this is 0 to 11, and then it goes 12 to 22, the same exact pattern, and then 23 to 33, okay? Now we have to go up to 44, so it would be wherever it was at. This would be 44, but we only want to go to 42, so if you back up 2, you can see what the y value would be, which is 2. Does that make sense? I think that's easier. The way she did it was go to 33 and then go up 9. I think it's easier to go to 44 and back up to 42, which is just 2 behind it. Okay? So it's asking what is y when g is 42. G of 42 is the same as g of 9, so the y value would be 2. Okay? I know. Exams start 2 weeks from today, like regular exams. I don't know. They haven't told us. What else? Are there other questions? Okay. This is, guys, you need to know this. You need to know this. You need to know this. Given a table of values, you should be able to tell if it's a log, if it's exponential, if it's linear, or it's quadratic, okay? In 3 of 4 of those, you'll see the changes happening in the y values, other than just counting by 1, okay? There's only one of them that the x's change, and that's log, okay? So when it's changing by multiplication, like 7 times 2, 14 times 2, that's called proportional. So when it happens in this column, it's a log. When it happens in this column, it's an exponential. So if we flip this, this would suddenly be exponential. Like the inverse of this, flip the x and y, it would be exponential. Okay. And then for linear, your first differences are constant, and then quadratic, your second differences. Yes, proportionally. Yep. 78. Okay. 78 gives you a rectangular coordinate, and they want you to find a polar, okay? And there were 2 formulas we needed to know for this. The first one was basically Pythagorean theorem. X squared plus y squared equals c squared, but c squared and r are c and r are the same thing. So x squared plus y squared equals r squared, which gives you 10 square root r equals the square root of 10. But really, you could have skipped that step because I go over it just in case on a test you do have different answers. But in this case, if I were taking the AP test, guys, I would totally skip that because they all have the same thing. You're not having to support with work, so why would I waste the time on that? And then the other formula is this. Tan of theta equals y over x. You need to know those formulas. And we're trying to find theta here. And this is the calculator portion. Good thing, because this is not one of the ones we know by heart. And whenever we're trying to find an angle, remember you use the inverse button. So it's second tan -3, and we get -1.249. But stop and be careful. Glad you asked about this one, Quentin. Remember, be careful because that answer is here, and that's the wrong answer. Okay? Your rectangular point is in quadrant 3. That means this one has to be in quadrant 3, right? To the left one up 3 is, quadrant 2. Sorry, quadrant 2. So this one has to be in quadrant 2. And when you do inverse tan in your calculator or inverse sine, you can only get quadrant 1 or quadrant 2. Right now we're in this quadrant, which is not quadrant 2, so we have to go here, which is adding pi. So I think I said quadrant 1 and 2. 1 and 4 is what you get on your calculator. If you need to be in either of these, you add pi. So when you add pi to that in your calculator, you will get 1.893. Say it one more time. Yeah, so if you do tan in your calculator and you have a negative answer, that you're automatically here. The only other place tan is negative is here, so it makes sense to add pi. So if you were pretend that we were actually in quadrant 3 for our rectangular point, when we put this in our calculator, we would have been in quadrant 1 because it would have been positive. -3 over -1. So my answer I would have gotten in my calculator would have been positive. So I would have said, okay, calculator gave me this. I need to be here, add pi to get to that quadrant. Okay, so that's an easy thing to forget. So I'm glad you brought that up, Quentin. $76. Here's another situation of me doing way more work than I have to. This is the calculator section, and if you remember that geometric sequences are modeled by exponential functions, you can use, look how easy this is, you can use your stat edit button. Let me clear my RAM. You can go to stat, enter, and I'm going to put my 2 ordered pairs in. So I have 4 and 7 are my x values, and 9 and 30.375 are my y values. Does that make sense? And then I go to stat, calc. This is an exponential, which is 0. Exponential. And I don't need to store it because I just need, do I need to store it? Yes, I do need to store it, actually. Alpha, trace, enter. When in doubt, just store it so you don't have to go back and do it. So I get the equation, but that's not what it asks for. It wants what g of 12 is. So where do I go to find the y value when x is 12? In my calculator. You remember? Yeah, that's right, the table. Go to the table and go to x is 12, and it would be 230.6880. I did it by hand first, too. I always forget that you can do this as a... Okay, well, why don't I come over and look at it? We'll talk about it one-on-one and look at it. What is? Yes, you were the one, Ty, that told me this. Ty gets credit. Well, Tanner's not here to get credit, so we'll give it to you. Let's not forget to talk about that. Okay. What else? How did I know? Because one of the formulas you're supposed to know is that for geometric sequences, you can use G sub n and G sub 1 or A sub n. You know what I mean? I kind of like G sub n better, but that's exponential. So the calculator will do it for you. So much easier. So much easier. Kitty? Okay, so I just kind of sketched a really, really, really rough graph. Okay, so in this problem, it gave you the minimum and the maximum, okay? The lowest point, graph not drawn to scale, just a sketch. Lowest point, highest point, okay? And it told us it was cosine, so I knew the pattern. And this comes before that, so I knew it started down and then blah, blah, blah. And that's all I have, okay? The question is, what are the values of B and D? So B is related to your period. So remember, to get B, we need to know how much of the x-axis we're using, and then we can use that formula. So if from 3 to 5 is halfway, then we would go to 7 to finish the graph, right? Because we know by the pattern of cosine, it's middle, up, middle, down, middle, up, middle, down. So that's the highest point. It's going to be right in the middle. So 3, 5, and then this would be 7. So right, 7, up, 4. Okay. So from 3 to 7 is 4. And I just plugged it into the formula. You know, remember, period equals 2 pi over B. And then, so I knew it was going to be A or B, right? And then the midline is in the middle of 4 and 8, right? So 4 plus 8 divided by 2 gives me the 6. Okay? Middle. So just like finding the midpoint between your max height and your mid height would give you the D. Sure. The height of the ground, blah, 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 let's find this first. T when T is 115. Do you have that picture? Okay, so I didn't know if that was it. So first thing I would do is type that in. I can't remember how to type this in. Do I need double parentheses there? I'm going to have to play with it for a second. I think so. 1 divided. Yeah. T plus 30 pi plus is plus 1. Oh, my picture looks nothing like that. Nothing. 42 sine. Oh, I forgot. No, I didn't. You see where I made a mistake, Corbin, anywhere? Let's try. Oh, I just realized what I did. No, I didn't. I thought I put in X instead of pi. I'll be with you in a minute, Quentin. On the second one? But what's wrong with the first one? So I don't think I need a double parentheses. Do you think I need a double parentheses right here? Why? No, that's the first one I typed in. I left it because I want to know what I did wrong with it. What is wrong with this problem? What am I doing wrong? Shouldn't you know that? Why is it doing this? Oh, it's not. I think it's okay. It's my window. I just had my window wrong.
Bro, the procedure yesterday, none of you were there. Bro, we started on the goal line. There was a ball. He threw a screen pass to the sideline.
Oh, good gracious.
He did that there and back. Yeah, I'm not. I ended up running it up. I just wanted to go. Sometimes it would be like, oh, coach, the ball's going up now. I was the only line left. Everybody else dropped. It's a little ball game. You just got to look for big guys. Wow. I said big, I didn't say that. Well, now you do. You gotta look for the horizontally count. No, horizontally count. Putting that screwed up.
Okay, I'm back, Quentin. I'm back. Yes, I just had my window wrong. Okay, so when we go to type this in, we have to do 42 sign, and then it opens parentheses for us, but where you have to put 1/20th in parentheses, or you could have put it in as a decimal without parentheses.
Oh, you want to do that?
Yes. And then x plus 30 pi. Close, thank you. Yep. Then I'm going to go to my window. I want from 0 to 120. Okay. And we could change the window if we wanted to see higher up. I don't know. No, did you change your window? Sorry about that. I'll get back to you.
It's all mental. It is all mental.
All right, bro.
Amos is weak to sleep in the body. So you're not playing spring?
Oh yeah, I'm gonna play Spring Runner Brothers. Yeah, I'm good at a week.
I did upload every project.
Here, Ross, take my seat. I need I'll stand up. I can't buy you a snigger like
Oh, good. I'm not worried about you at all.